In the lesson on joint distributions, we considered the example of two friends, Xavier and Yolanda, who bet on reds at a roulette wheel. They both make 3 bets before Xavier has to leave. Yolanda continues making another 2 bets. In that lesson, we worked out the joint distribution of x, the number of bets that Xavier wins, and y, the number of bets that Yolanda wins, and we wrote the joint PMF in a table. The question we will answer in this lesson is, can we recover the distribution of x alone from the joint PMF of both x and y? Remember that the PMF of x is just the probability that x equals little x as a function of little x. If we wanted to know, for example, the probability that x equals 0 from the joint PMF, we would add up the probabilities in this column, corresponding to the outcomes where x equals 0. Likewise, if we want to know the probability that x equals 1 from the joint PMF, we would add up the probabilities in this column, corresponding to outcomes where x equals 1. And so on for the probability that x equals 2 and the probability that x equals 3. These probabilities in blue are the PMF of x at 0, 1, 2, and 3 respectively. Because it is natural to write these column sums in the margins of the table, this has come to be known as the marginal distribution of x. Here is the formal definition of a marginal distribution. The marginal PMF of x just refers to the PMF of x when it is specifically calculated from the joint PMF of x and another random variable. We calculate the marginal PMF as follows. For each value of little x, we need the probability that the random variable x equals little x. And we calculate this by summing the joint PMF over all the possible values of the other random variable, in this case y. Just to untangle this formula a bit, this little x refers to the value at which we are evaluating the PMF, whereas this little y is a variable that we are summing over. Notice that we use the symbol f sub x for the marginal PMF of x. This is to distinguish it from the joint PMF, for which we are already using the symbol f. This also distinguishes it from the marginal PMF of y, for which we use the symbol f sub y. In general, we will use subscripts to indicate which random variable this is the marginal PMF of. Here is what we are doing graphically when we calculate a marginal distribution. Recall that a joint PMF can be represented as a 3-dimensional graph. There is a bar for each possible outcome, and the height of each bar represents its probability. Now, when we calculate the marginal distribution of x, we are summing over the possible values of y. We can think of this as stacking the bars across the possible values of y. Once we have done this, we are left with just a distribution over the possible values of x, and that is the marginal distribution of x.